Okay, this is MAT175, Lesson 4, Sections 11.1 and 11.6, and we're working with system of linear and nonlinear equations. Okay, we're going to solve a system of linear equations using the substitution and the elimination methods. And here's some examples of a system of equations. Here's two linear equations with two variables, x and y. Here is a system of nonlinear equation with linear, kind of a combination of the two. Here we have a system of three equations with three variables in it, and again we have two equations containing three variables. Here it's missing a z, but it's because this has three variables in it, we count all three. And here we have a system of four equations with 1, 2, 3 variables in it, x, y, and z. So those are just examples. Now, when you have two linear equations like this that intersect at a certain point, that point of intersection is the solution. So, back up here, if we were to solve for x and y and find what x and y are, that would be this point right here. And this has one solution in it. So this would be considered a consistent system, and these equations are independent. Okay, here we have two parallel lines where there is no intersection at these lines, so there would be no solution because the lines never intersect, and so they would be considered an inconsistent system. And so there would be no solution, and it would be an inconsistent system. Here we have two lines. So if we were to back up, if we had two equations like this, and basically all the x and all the y values, variables canceled out, and both sides equaled, then you would get with one line is on top of the other line or superimposed on the other line. So you would have an infinite number of solutions because the entire line from both equations is the same once you solve for y, for example. So the lines are coincident. The system of equations has infinite many solutions in it. And so this would be a consistent system, and the equations are considered dependent. So the main thing that we are concerned with is that there would be an infinite number of solutions. So let's say we wanted to graph. One way we can find a solution is by graphing the system. And we do that by isolating the y and putting it in slope-intercept form. So the first equation, subtracted 2x from both sides, divide everything by 3, we get y equals to negative 2 over 3x minus 1. Here if we were to apply minus 4 to both sides and then divide everything by negative 1, we get y equals to 4x minus 3. So if we go to graph that using the slope-intercept method, we get a solution at a certain single point. So we can see that the two lines intersect at point 37, negative 9, 7, which is the solution. These are independent equations, and you have a single solution of 3, 7 and negative 9 over 7. So that's using the graphing method. Solve the system of equations by substitution. Okay, so here we have our same equations again, and we want to pick one of the equations. Well, the easiest one to pick is you want to try to find one that that has 1 as a coefficient, and then solve for that. And it could be x or y. You could solve for either x or y. Whichever one has a coefficient of 1, that's the one you want to solve for. And So we get y equals to 4x minus 3. We solve for the y here. Now what we're going to do, it's like you're cutting out the y for the first equation, and you're going to put parentheses. And then what you're going to do is you're going to substitute this equation in for this y value here, and that's what you have here. So you want to look at this like you're cutting out that y, and you put parentheses, and then you're going to substitute that equation in. So now we distribute the 3, excuse me, and then simplify from there. So from this point, you get 2x and 12x is 14x. Apply plus 9 to both sides and get 3. You get 6 rather, and then divide by 14 and simplify that, and you get 3 over 7. Okay, that's our x value. We still have to find the y. So what we have to do is pick one of the two equations. Doesn't matter which one, just pick one. So we pick the second equation, and whether you substitute it in for y equals to 4x minus 3 or substitute in the original equation, that part really doesn't matter at this point. So we substituted in 3 over 7 and excuse me, into 4, and from there we simplify it, and we get negative 9 over 7. Okay, and so that's our solution. Okay, now we want to solve the system of equation using the elimination method. And what we want to do is interchange any two equations of the system. Multiply or divide each side of the equation by the same non-zero constant, and then replace the equation. And you're going to either add or subtract to eliminate one of the variables. So here's our equations again. And so what we need to do is we need to eliminate either the x's or the y's. So because this is a plus here and the y, this y is a minus, if we multiply 3 here into this y, then you'd have a plus 3y and a minus 3y, and we can eliminate the y's. But you can't just put a 3 here for this y. You have to put the 3 into all the terms. So we have to distribute the 3 here, and that gives us 6x minus 3y, and then we also have to multiply the last term, equals to 9. Now we can eliminate the y's because we got a plus 3y and a minus 3y, and that's the whole idea. And so the y's go away, and we get 2 plus 6 is 8x equals to 8, and we get x equals 1. Well, that's the x variable, but we still have to find the y variable. So we have to substitute this x into one of the two equations. Doesn't matter which one, just one of them. So in this case, we substitute it into the second equation, and then that gives us a 2 minus y equals to 3, and we end up apply minus 2 to both sides, and we get 1, and then divide both sides by negative 1 to get that negative over, and we get y equals 1. So to check it, we want to, whatever we found, whichever equation we use to find, in this case, the y, we have to use the other equation to check it. Because if we use this one here, if we made a mistake, we won't find if we made an error or not. But we will if we put it into the first equation. Okay, so our solution is 1, negative 1. Okay, identifying an inconsistent system. And remember now, inconsistent means there is no solution. The lines are parallel. Let's see what happens here. Here's our system of equations, x minus 3y equals to 2. And we're going to go ahead. In this case, x has the 1 coefficient, so we're going to solve for x. Apply plus 3y to both sides. We get x equals to 3y plus 2, and now it's like we're cutting this x out of the second equation, and we put parentheses in there, and then we're going to substitute this equation in for it. And there it is. Here's the 3y plus 2 goes into this x here. Distribute the negative 2. We get negative 6y minus 4 plus 6y. So the 6y's, they go to 0. And now all the variables are gone. And we just get negative 4 equals to 1. Well, when all the variables cancel out and both sides don't equal, then that means there's no solution. The lines do not intersect anywhere. And so there's no solution, and this is called an inconsistent system. Okay, let's try. And so that's what they would look like on the graph. They don't intersect anywhere. There's no common point. Now we want to express the solution of a system of dependent equations containing two variables. Okay, so let's see what happens when we get a dependent system. Again, we're going to go ahead and solve for x because it only has a 1 coefficient for the x. So we apply plus 3y to both sides and then substitute that in to x into the second equation. And we get negative 6y minus 4 equals to 6y, plus 6y rather, equals to negative 4. So again, the y's cancel, so you can see that this is a slightly different problem than the last one. And so now both sides equal. So all the variables cancel, both sides equal. So that means not only is there solution, both lines are on top of each other, and there's an infinite number of solutions. Since these statements are true, but we have no variables, the two equations are equivalent. So these are dependent. This is called a dependent system, and there is an infinite number of solutions. So in this case, what we would write is x, y, and then we would write the equation. In this case, we wrote it just like we wrote here, x equals to 3y plus 2. So this would be the set of both x and y, given that x is equal to 3y plus 2. And basically what this is saying is that both, if we were to solve for x on both of these equations, we would get the same equation. So if we were to apply minus 6y and then divide by negative 2, you would see that you get the same thing as what you get here. So we have an infinite number of solutions there. Okay, now we're going to look at nonlinear equations, like parabolas and so on. Well, let's see what happens there. If the system contains two variables and if the equations in the system are easy to graph, then we can graph it, and then we can get an idea of how many solutions there are, and then you have to be careful of any extraneous solutions that can also be in this nonlinear system. We have to check it. You have to check your work, because if you don't, you won't be able to know if the solution that you have is a false solution or an extraneous solution. Okay, here we have our system of equations. Here's our parabola, so we know it's nonlinear. So in this case, we're going to go ahead and use the first, look for the, we can go ahead and graph it. Let's see what that looks like. So basically, if we apply the minus x squared to both sides and divide by 2, this is the second equation, the parabola. Right here, this would be the first equation. Basically, what you're doing is you're solving for y, and then you plug in that equation into your calculator to see where your solutions are. And so basically what we do is we went ahead and solved for y to the first equation, substitute it into the second equation. It's like you're cutting that y out, put parentheses, and you distribute that too. And then at this point, you can go ahead and you're going to factor, because we have a quadratic, and set it, since it's set equal to 0, and we get factors of x plus 2 and x minus 6. So we set each factor equal to 0, and we get x equals to negative 2. Well, here's x at negative 2, and here's x at 6. But we need to find the y values. So one at a time, we have to substitute them in to the other equation and find the y value. So here we take the negative 2, substitute it back into this equation, and we get negative 2 times negative 2 is positive 4. Positive 4 minus 6 is a negative 2. So that means that this point here is a negative 2, negative 2. And then we take the x equals 6, substitute that back into this equation here, and we get negative 2 times 6 is negative 12, negative 12, negative 6 is negative 18. So that means this would be 6, negative 18 for the second point. So you don't want to be totally reliant on being able to graph these on the calculator. You have to be able to algebraically show how the work is done. Okay, and there's our two solutions. And you can check it, since we used the first equation to find the y values. You can use the second equation, substituting x and y in, to see if both sides equal. Again, if they equal, then you know that it's a good solution. Well, we got to check it, right? And so 6 and negative 18, you would substitute that in, and both sides should check for that as well. Solve a system of nonlinear equations using the elimination method. Now you can do that with this one, but the last one, it was easier to use substitution method because both of them didn't have x squares in it. We had a linear equation and a quadratic, but here we have two quadratics, so we can eliminate the x squares. And the way we would do that is we would multiply. We want to get at least one positive x squared and one negative. So we want to multiply negative 1 either into the first equation or the second, and it really doesn't matter which one you multiply into. So we know we're going to have at least two solutions looking at our graph. Here's our circle, and then here's our parabola, the second equation. So this problem, what they did is they multiplied a negative 1 into the second equation, made that negative x squared minus 2y, negative 1 times x squared, negative 1 times 2, and negative 1 times 0, and that gave us a negative x squared and a minus 2y. So that gave us a positive. So now we have a positive x squared and a minus x squared, and the x squareds cancel. And here we have a y squared. Well, the y squared cannot be added or subtracted with the 2y, so the y squared comes down here. And since we multiplied everything times negative 1, that would make this a minus 2y. And then the 8 and 0, that's just 8. 8, plus 0, that's just 8. But because we have a quadratic, what do you think we got to do here? Now, pause the tape and try and see if you can solve for y here. Okay, go ahead and pause it and give it a try. Okay, let's see how we did. First thing, what's the first thing we got to do? Because we have a quadratic, we should have set it equal to 0. So we had to apply a minus 8 to both sides. And that gave us y squared minus 2y minus 8 equals 0. Now, how are we going to solve it from here? We're going to factor it. And what are the factors going to be? First of all, what are the signs going to be? You should have had opposite signs because our c term is a minus. And then factors of 8 are going to be 4 and 2. Y minus 4 and y plus 2. The 4 has to be a minus because if you were to multiply the two inner terms and the two outer terms, you've got to get minus 4y and a plus 2y to give you a minus 2y. So this is the only way you can factor it to get this middle term to come out right. So you should be checking to make sure your factoring comes out. Now we set each factor equal to 0 and we get y equals 4 and y equals negative 2. Well, here's y equals negative 2, but y equals 4 is way over here somewhere. So what do you think happens there? That's going to be extraneous, right? That's going to be an extraneous solution because there is no intersection for y equals 4. So graphing these solutions, they can your equations that can quickly show you if your solution is extraneous or not. So now we know that y equals 4 cannot work. So now we have to take y equals 2 and substitute that, our negative 2, and substitute that y equals to negative 2 into one of these two y's. Doesn't matter which one as long as you do one of them. So we went ahead and substituted into the second equation, and we get x squared equals to negative 4, and then apply plus 4 to both sides and get x squared equals to 4, and then apply the square root and get plus or minus 2. So our solution here is we already have y is a negative 2. That's going to be for both x coordinates. So that's where you get your negative 2, and positive 2, negative 2 for x is plus or minus. Okay, and those are your solutions. Okay, solving a system of nonlinear equations. And now we have equation of a circle here, so we want to go ahead and graph it. Well, what do you think you're going to get for solutions here? You should get no solution, right? Because there's no point of intersection here. So if we were to go ahead and solve for x and then substitute that back into, cut the y out here in the second equation and substitute that in, we have to square this equation, right? So basically it's like you're putting in a copier and hitting two copies and FOIL, and we get x squared plus 4x plus 24 plus 36 equals 1. Well, we can combine like terms here, right? And you get 5x squared. Bring that 1 over, apply minus 1 to both sides to get it equal to 0. And anytime you have a leading coefficient larger than 1, you want to see if you can divide that out or factor that leading coefficient out to simplify the trinomial. But in this case we can't do it, so we want to go ahead, cannot factor it either, so we have to use the quadratic formula. So in this case, the 5, that would be your A, the B is 24, C is 35. And we would use the negative b plus or minus the square root of b squared minus 4ac over 2a. And so you get negative 24 plus or minus 24 squared, and then minus 4 times 5 times 35, and you get a negative 700, square root of negative 700 over 10. Well, because this is negative inside the radical, that's where algebraically you show there's no solution. You don't get a real solution. It comes out imaginary. So actually together with the real and the imaginary you get a complex number. But in any case it's still no solution because of this negative radicand. So it's an inconsistent system with no solution. Okay. Here we have a nonlinear equation, and we're going to use the elimination method. So there's no straightforward way to graph it. We just go ahead and apply it algebraically. So we can go ahead and multiply this x out here, multiply x here, and that cancels those x's out. But you have to multiply x here, multiply x with x, and you get x squared. Multiply x times 1, you get x. Multiply x here with this term, and the x's cancel. Multiply x times 0, and you get 0. And so when these x's cancel, that's where the y squared minus y comes in. Okay, so at this point, we can go ahead and see, alright, we want to try to eliminate, let's see, first of all, if we can combine anything. There's nothing to combine here, but we can go ahead and apply a negative to the bottom. So we multiply negative 1, multiply negative 1 here, multiply negative 1 here, multiply negative 1, multiply negative 1 times the 0. And when we do that, negative 1, this becomes a negative 1x squared, and positive 1x squared. The x squares cancel. And then this would be multiplying negative 1 here. This would be, that would make that a negative x, and that would make this a positive x. So those, the x's cancel. And that, so multiply negative 1 here, you get a negative 1y squared, a positive 1y squared, and those cancel. And when you multiply negative 1 here, that makes it a plus y. So a plus y and a minus 3y, and that gives you your minus 2y. And then you bring, there's nothing to add or subtract with this 2, so you just bring that down. And of course, 0 plus 0, that's just 0. So we've been able to eliminate all but the 1y. And so that's the whole idea, is you want to bring it down to one variable so that then you can isolate that variable and come up with, you know, at least one of the coordinates. So now we can apply minus 2 to both sides and then divide by negative 2, and we get 1. Y equals 1. Well, what do you think we have to do at this point? Okay, you should have said that you're going to substitute that back into either this y here in the first equation or this y here in the second equation. Well, since this equation, what they did is they used this second equation here after we got rid of that denominator. So we substituted y here. Oh, no, wait a minute. Let's back up. Okay, now at this point, we've got y equals to 1. So now we have to substitute that back in to one of these two equations. Okay, so we are going ahead and substituting the 1 back into the first equation. And so that's x squared plus x, and where the y is, we put a 1 there. So that's y squared, and that's going to be 1. And then we're going to substitute 1 into this y. And so we get 1 minus 3 is a negative 2, and negative 2 and positive 2, so that all goes to 0. And we end up with x squared plus x equals 0. Okay, now at this point, solve for x. So pause the tape, or the video, and try to solve for x at this point. Go ahead and try that. Okay, now here, you're going to have to factor the x out, common factor, and then set each factor equal to 0. So if you did anything else but that method, it's not going to work out. So you get 0 and negative 1 for the x solution. So this would be, it won't work. Your only solution here is x equals to negative 1. And that concludes this lesson.